Hey everybody. A lot of people had questions about page 1 of the math packet, if you were able to get that last week. So I wanted to talk a minute about scientific notation. So here you see 3 problems that were on your packet, and I know it's not beautiful here, but please excuse the artwork. You guys know I'm a fabulous artist. So the point of scientific notation in a math classroom, in a science lab, and in many other places is often to express really big numbers or really small numbers without having to write 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Instead, we can use scientific notation and we use a number between 1 and 10. That's kind of the general rule. And then we say times 10 to the whatever. If it's 10 to the -2 or the -3 or the -4, that's going to indicate a really small number. And if we see something like this, a number between 1 and 10, and we have 10 to the 5th power is what that's supposed to be, then we're talking about a really big number. But again, if you don't want to write all those zeros that would come after that, then scientific notation is a way to express that. This here is numeric form, just writing the number. So in your packet, you were asked to change these two to numeric form and change this one to scientific form. So you're basically going back and forth between two forms of writing a number. So let's tackle these. So you're going to remember this after you see me do this, if you forgot. When I see 10 to the -3, automatically I know, okay, I'm going to be drawing or writing a small number. This indicates a really small number. So if I just think about it, if I'm going to write a small number, am I going to move this decimal to the right, or am I going to move this decimal to the left? Which would give me a smaller number than 5.421? And you guys are probably remembering, oh yeah, this is where you start at the decimal, and since it's 10 to the -3, I'm going to have to move back 1, 2, 3 spaces. Okay, and that way my new decimal goes right here, right there, right there, right there, and I have a 0 and another 0. That decimal right there is going to disappear, and then this part would disappear. So rewritten in this beautiful form, let's change the text here, we know that we would have 0.005421. Okay, so I just changed that from scientific form or scientific notation, we changed it to a numeric form. Okay, let's get another one. Okay, let's get my pen back here. How about this one? 7.31 times 10 to the 5th. Well, 10 to the 5th power means 10 times 10 times 10 times 10 times 10. That's a big number. That's a lot of zeros. So obviously we know we're going to have a much bigger number than 7.31. So which way would I move the decimal to make that happen? I would move it 5. So 1, 2, 3, 4, 5. If I'm visualizing this, right? So this is not the best format to show this, but if I rewrite it, then I'm going to have 7, 3, 1. And then how many zeros am I going to have? It looks like 3 zeros. 1, 2, 3. Okay. And I can check myself. What if I went the other way? 1, 2, 3, 4, 5. Bam. If I went the other direction, if I have this big number and I said times 10 to the -5, I'd go back 1, 2, 3, 4, 5. I'd be back to what I started with. So I know that this is the right number, which is 731,000. That's just beautiful, I know. Okay, so we'll take that off. So hopefully that helps you remember how to take something in scientific notation, rewrite it in numeric form. It's really about just following directions. You follow the directions that the exponent gives you. If it's a negative exponent, I'm making a smaller number, so this decimal goes to the left. If it's a positive exponent, I'm making a bigger number, so this decimal place goes to the right. However many spaces it's telling you, that's how many spaces to go. Now, this guy right here, this is in numeric form. We got a lot of zeros here. If a scientist is looking at the size of a cell under a microscope and they are writing some sizes and some different things down, and they don't want to write all of this every time, they can simply do this. We're going to take it to be a number between 1 and 0. So we're going to let this be 6.22. Again, I know it's beautiful. Okay. Times, I should be using my text feature, 10 to the what? Now I got to decide. Okay. So to go from this to that, okay, I would have to move how many spaces? 1, 2, 3, 4. So that's 4 spaces, but the question is this positive or negative? Because if I want to take this thing and make sure it is equal to that, well, 10 to the 4th power, that's 10 times 10 times 10 times 10. That's a big number. I have a really small number. So hopefully you understand that this is 10 to the negative 4th. A scientist could write 6.22 times 10 to the negative 4th, which indicates a very small number, because if I start right here and I go back 1, 2, 3, 4 spaces, then I'm going to have these 3 zeros here, just like here. 1, 2, 3, 4. So this is the same thing as this, except this is numeric form and that is scientific notation. But that 10 to the negative 4th shows me that this is a small number, much smaller than 6.22. And we know that 0.000622 is a small number, smaller than 6.22. And that helps us check to make sure we did it right. Hope this helps.